Some people I know, some people I don't. I am going to talk about Elixir today. I've got a lot of material, and I tried to set it up so it starts out a little bit and then works up into some more advanced topics. And there might be some time at the end to do some live coding together, or even earlier on. So some of you have used Elixir before, and I assume you guys all are coders of some sort. Most of you are developers, I would guess. Anybody not a developer? Okay, that's good, Mariana. All right, well then you're going to learn Elixir today. These are my drawings. I found them in one of my old scrapbooks, so I've been use them in this thing. So here's the Elixir guys. Elixir has been around, actually. It was based on Erlang, and it's been around for a long time. And it's just kind of one of those things. It's just kind of a humble technology that just works, and it's getting a lot of attention through Elixir. And so this is sort of the detractor of Elixir. Usually somebody thinks it's very specialized and very functional and very funky, and so he's not happy. So and I'm gonna. This is. Do we have the swag, Thomas or Wes?
It's in the back.
Okay. So I'm not originally from Finland. I'm from the U.S. originally, and I've been in Oulu for 30 years on and off. Oh, thanks. And so my presentations are different than your typical presentations in Finland. So I expect participation and paying attention. And I even have awards in here for people who answer questions correctly. So when you see a swag symbol, that will be your opportunity to. Anyways, what was I saying? Yes, so I'm right now I work at OP Labs. This actually we're in Boyo Works, which is with OP Labs. I've worked at other places in Oulu and in the US and different places. If you're interested, come talk to me afterwards. But I've got so many slides, so I'll just move along.
And you worked with a guy named Bill Gates as well.
I was at Microsoft. I did work on the original Media Player 1.0 in 1993, which was really cool. We made Windows actually play video, so that was a long time ago. Yeah, I worked for Bill. So actually, here's a reference to that. So I also have some blogs on my GitHub site if you guys want to see some of that. Actually, I'll refer to some of these blogs. I've been using Elixir for about 4 or 5 years actually now. Using it and over the time I've written some different blogs, especially when I started out. I wrote a bunch of blogs about Elixir. Some of them were very popular. This one actually was the top of Reddit programming for a while. It was really strange, out of nowhere. I just wrote this rant about why JavaScript has got all these issues, and people started arguing with each other over my blog. It was really funny. And somebody else actually came to me and said, "Hey, have you read this blog? This guy's really stupid," or something. I'm like, "Wait a second, that's my blog." So. Who's using Elixir? I always have to start out with this slide. Lots of people use Elixir. Actually, 90% of the first thing is when I say Elixir, I could also say Erlang, because Erlang is what's behind Elixir. So Elixir is, I have a slide about that in a second, is something built on top of Erlang, and it really leverages everything that Erlang is. So Elixir owes its stability and its safety and all of these things to Erlang. But I have some slides about that. But 90% of the internet goes through Erlang nodes. So yeah, you could say Elixir is all over the place. These companies, you can read blogs online about where Elixir is being used. WhatsApp, for example, very light story of how they scaled to 100 million users with just 10 engineers. So with a very small number of engineers, they created a massive connected service that's very cost effective. At OP, I'm proud to say we have the first Elixir production system at OP Bank. And it is face payments, the back end for face payments. Actually, you should watch this video, it's hilarious. It's a Swedish one. The funniest part is when Sami in Helsinki goes, "Shit, it's my Siri," and they played this on Swedish TV, but anyways. So we actually are using OP, we are using Elixir in production. So it took me only 4 years to actually convince the Java people that there's something else than Java. So it went through our security audits, it went through naysayers. Actually, that first slide showed one of the people we talked to. The whole coin impossible future was because somebody said, you will never take this to production. And then now they're actually loving it and want to use Elixir in their projects. So we actually have 2 other projects at OP that are now also starting to use Elixir, and they're liking it. So we've overcome that. So anyways, instead of going forward, I'm going to go backwards. So number 1, Elixir is different. I know you guys you probably work in Java and JavaScript and Go. What do you work? Let's see, how many people work in Java? Hands. Java, JavaScript, Node.js, okay, a lot of you guys. How about like Scala or some of the more, okay, that's good. Function Clojure, anybody Clojure? Go, Clojure, Go, okay, good. Anybody, any languages I didn't mention? Python? Yeah, I knew, okay. Ruby, oh, I forgot Ruby. Sorry. Okay, so all you guys, first thing you do when you see a language like Elixir, you just start trying to compare it to what you know already. Okay, then you have to stop right there because it's different. And it's going to really twist your brain a bit unless you understand. If you come from Clojure, then it's not so different. Or Scala, maybe you're like, okay, yeah, this is obvious. But for others, it's going to be pretty strange. So though normally I use Visual Studio Code. I'll show you some examples there. And there's a couple of plugins that I use. By the way, you guys have laptops? Where's your laptops? What the heck? Jesus Christ. You're supposed to come to these things with laptops ready to code. All right, there's the clone the top GitHub repo on my site, and you'll get all of the slides and the example code in that repo. So if you want to play with it, you can look at the code yourself. So it's I am github.com, Tom Joro. I'll just click on it for you guys. I mean, I went through the trouble. What? Why is that? Did I do something wrong? What? Demo effect. I thought it was there. Let me just see. What am I doing wrong? Yeah, really. Just put it up there a second ago. Okay, here I am. Also, my blogs are up there too. Repos. It's not. Shouldn't be. Should be public. Elixir Safe Practical. Somebody, can you try and see if you can see that? It should be public. Is it private? Did it say? Yeah, it's public. Okay, good. So code is here. Part 1 is what I'm talking about here. There's some examples if you want to see them up close. Oh, sorry, yeah. Wi-Fi was what? Password? Oh, on the wall there. Boya works. Okay, good. Okay. So in the slides, I'm afraid they are PowerPoint because I can convert them to something else. But if you want the slides are here as well. So it's a self-referential presentation. Okay, so getting started. This is, I want to show you something about Elixir. There's actually an example about immutability. Now, Scala Clojure people know this. So in here, I'm creating a map, and here, this is you call it a hash or a map or everything else. I've got safe is true, practical is true, and this is a map. It's a hash map. Everybody else hash map. Now, if I'm going to change this map, I want to add something to it. What I have to do is I call map.put my map. So I take this map here, and I add fun true, so I get a new map. So the thing here is that, number 1, it's not object-oriented. There are no instances or objects or methods. It's purely functions and modules. So this is the name of the module. This is the name of the function. This is the data structure I'm passing to it. So doing this, I get a new version back. Now, if I try to take my map2 and add mutable to it, mutable false, actually it is here, but if I check my map 2, it's not changed. So it's not changed because I didn't save the result. The my map 2 returns the new my map. I would have to save it. I have to name it in order to keep it. But so you can never change actually the value. Immutable stuff cannot be changed. And you have to understand that in Elixir, everything is immutable, meaning you always are calling things and taking the return value. You can't pass something into it and it changes it, and it's like magic. So I'll tell you some more about this. So actually, interesting enough, in Elixir, this is another thing that people's minds get twisted about, because this actually is illegal in Erlang, but it is actually doable in Elixir. And that is, I'm going to reuse the name my map 2 and give it something else. That's not violating immutability. It's actually just giving it a new name. The old thing still exists. It's just that I reuse this name, variable name, for something else. So, do you guys understand that? Yeah? Well, we can try some code examples in a second. So, here's a quiz. Oh, swag. That means I've got a prize. On Elixir, we have, okay, here's Ruby. Thomas, ready?
Yeah.
Okay, my map takes, okay, I create a map and I put 2 things in it, right? It's practical and safe. Okay, then I've got some class, I'm not telling you what it is. So there's some class, I'm creating a new object on that class and I'm calling a method. And then after that's done, I'm going to print out what was the value of map now, okay? Here's Elixir. I'm doing pretty much the same thing. I'm creating a map, and then I'm going to call some other module and a function. I'm giving it this map. And then afterwards, I'm going to print out what it is. So the question is, number 1, maybe we should do the Ruby first. So what's the value of, what is this going to print out?
We don't know.
Yeah. What's the method?
Exactly.
No.
What is this going to print out?
Same stuff.
The same stuff. Okay. Auntie wins the prize.
I just want some candy. Come on, give me candy.
No, I don't know what. This is like green bar stuff. There's patkis here.
Yeah. Thanks.
All right. Auntie got the first one. So immutability means that when I look at this code and I see this my map, no matter what I do, who I give it to, it's never going to change. I always know what it is. So in a language that allows mutability, when you call a function, it can change this, and you don't know what it does. So you have to go look at the code to see what it does. So this is one thing about Erlang and Elixir, is that the idea also is the code is very simple, very readable, very predictable. So questions? You guys have questions, just shout them. Okay. Now just to even, oh, I don't know if I need to give swag for that. To show you actually how immutable, I'll show you another thing here. So here I have some new things, module. In Elixir, everything is in a module. So a module is just a group of functions, okay? And a function is like this function. So you notice it's def module, do, def func, do. It's kind of Ruby-ish, the syntax. In this first function, I say a is 3. Then I'm going to call function 2 and pass it a. I'm going to do an if else. And then I'm going to print out this. So this here in Elixir, the last thing that's evaluated in a function is the return value. So you don't need any special, there's no return. It's just the last thing that it does is returned. What was the question here? The question here is, first of all, is there an error in this program? And this function specifically? Will this even compile? Elixir does compile, by the way. So who can guess the error? Auntie's not. And Nicholas and Ilya are disqualified.
Is the C only in the if true block? Is the C defined in the puts?
It's not defined, correct. because it's scoped to this if-else block. That's good. All right, you get this back. What do you want, Patkeys or health bar?
Our back is there.
Yeah, okay. All right, anyways, next slide. Anyways, I'll come back to this one. So,
Just for information, there's only 3 back.
oh, okay.
Now it's on.
Okay, so there I'm like, really this like an if-else statement works like a function? It's like scoped that you can't even leak any variables out of an if-else, and that's actually true. So if you actually have an if statement and you really wanted to return something out of the if statement, you actually have to, this is what it's returning into here so that I could return it from the function. So the immutability goes deep, right? So every statement has got immutable stuff. You can, of course, take things into the function, but you can't declare things that come out. You can bring values in, but not out. That's lexical scoping. So, you like my drawings? So, okay, let's write a loop. Loops are very important. In fact, my brain, I've been programming many years, and I always think of things like, oh, it's a loop. Actually, there are no loops in Elixir. There's only recursion, but don't get hung up on that. So here's this module. Module name is loop. Here's where I'm going to start it, actually. When I give this to Elixir, actually, you can just do it like this. If you have the code and you have Elixir, which hopefully you installed, but nobody told you to do it before now, so oh well. Anyways, you run it, and it'll start the loop. It goes up here, calls loop 5. So loop 5, let's see, it says loop 0, that doesn't match. Let's try the next one. Loop -1, that doesn't match. Okay, loop remaining. Oh, okay, this is okay. The value of 5 goes here. Now I start running this here. This is a guessing game. You get 5 tries to guess my age. It checks in this conditional. It's like an if-else. If it's less than, it says guess higher, or greater, less than, higher, lower, or not. And then it does loop remaining -1. So now it was 5, it's now 4. It calls it again, it starts, oh, it's not that, it's not that. Okay, here, so go 3, 2, 1. Eventually it gets to 0, and then you run out of tries, and it's done. So that is a loop in Elixir. There's no while, there's no do until, there is only recursion. But for you math people, recursion is equivalent to looping, actually. Recursion guarantees anything you can do in a loop can be done in recursion. And in Elixir, because Erlang is a tail-safe recursion guaranteed, you can actually loop infinitely without blowing up a stack. So, questions about that loop? I'm going to refer to this loop, so it's important you understand loops.
Just wondering, does it provide these basic primitives like loops and that kind of stuff?
Nope.
Or you need to make, like, in the beginning of the project, you will define the loops. And
you make them in your code. If you need to go around, actually normally you use, I'll show you in a second, normally you use a standard, like if you need to filter a list, you call filter and you give it the list and it does the looping.
that was many.
Yeah, you're not going to write raw loops, no.
Every project like extended in
No,
language.
no, absolutely not. So now we'll jump to processes. So you guys know threads, processes. What is basically at the heart of a thread or a process that keeps on running? There is a loop. Either that or it's a sleep, infinite sleep, but we don't consider that case. So at the heart of any, so you start a thread and it's going to run. I mean, or you start a process and it's going to run, which starts a thread. In order for it to run, continue to run, there has to be a loop. So processes are loops. Okay. In Elixir, we actually have the concept of a process, which is essentially this code, which is looping around, and it has its own memory. Elixir is built on processes, and a process has one thing. It has 3 things. It has the thread or the code that loops around. It has memory, and it also has a mailbox. So you can, in this case, what I've done is if I start this loop here, in it, what it does is call spawn loop 2. So this is what we call an MFA, module function argument. This says there's a module called loop 2, there's an init function, I want you to spawn it. So it starts a new process over here that starts running, and then it calls loop PID, so it comes into here, and it says send the message, so it sends that guy. It knows that process from its PID, that's a process ID, and then it sleeps for 1 second, and then it recurses on itself to loop, and it keeps going forever. And so it will send a message every second to the other process. Simple, simple concept, but this is actually the heart of processes in Elixir or Erlang. You guys are all thinking, you guys need a demo. That's what it looks like here. Let's do some code. So if you have the code in front of you, or if I can, just so you guys don't think I'm just making this stuff up, I'll show it to you. Where's it going? Okay. So normally, Visual Studio Code, open, let's go, Talented Live Part 1. Here's the code. Oh no, that's not what I wanted. Sorry. That's the Part 3 code. 1. Okay, there should be loop. Here it is. So, process loop. Here's the first part. I probably need to make it bigger. This is not set up for group coding, Thomas. Can you see that?
If I push this forward.
Oh, that, yeah, that'd be good. Okay, perfect. So there's the first loop, right? This is the one that's going to send a message and start the other one. So here's that. Here's the other loop. This one just prints out what it receives. So here's a very important statement here, which is the receive part of it. So on the let me put these side by side. Too hard to work without a mouse. So this is an Erlang or Elixir primitive to send a message. You give it a PID, meaning the process ID of who you want to send to, and you give it a data. On the other side, I'm going to do receive, which is another Elixir thing. It's pretty obvious, send, receive. The receive actually blocks until there is a message in its mailbox. And so what it does is it'll just receive it and print it out, is what this line is doing, and then it calls loop again because it wants to keep running. So again, it does recursion. So here we have two processes, and terminal, like new terminal. It is. Just all inside of Erlang, Elixir. So what I can do here, I'm in this IEX. I should explain what I'm doing. So when you get Elixir, just like Ruby or most languages, you get a little interactive terminal thing. That's called IEX in Elixir. This starts the virtual machine where I can run stuff on. In this case, I'm running interactively, so I can do all sorts of things. For example, I can tell it to, compile process loop1.ex. Why did I not, where am I? Whose directory I'm in? What did I do wrong? Bureaus, processes. Sorry. Normally you're not doing this stuff by hand. You're using some package managers and stuff, but I'm just showing you for. So what it tells me now is that it loaded and compiled and it didn't get any errors. So actually this is kind of cool because now I have this module. I can ask it loop 1. If I hit tab, actually it says there's two methods here. There's an init method, which takes no arguments. There's a loop method, which takes one argument. So, that means that it sees both methods. I can call either one of them. just by typing them. So let's first compile the other module, because if I run it now, it's not going to work very well because the other guy's not going to answer. So let's not do that. Processes, I should have made these easier names. EX live coding. Okay, now we have both of those loaded. When you load a module in Elixir, it's global. So those modules with functions are visible to everybody all the time. There's no fancy like Java naming, hiding stuff. Modules are just everywhere. Your module is seen everywhere. It's very simple. So you got a module, you can find it by the name. You can make nice long names by adding dots and stuff in them and make your own sort of namespaces. But fundamentally, a module, a group of functions, is visible to everyone. So if I do this loop one, what do I want to call init? It's got a nice inspector. I'll call it there. Guess what? It actually works. Two processes running, talking to each other. And this will go on forever. Actually, in the face payment project, we have been running now at OP, our Elixir server, for over a year, which we set up originally in development and went to production. And it has never failed a single time. It's never gone down for any reason. Yeah, go ahead.
One thing that arises to my mind is if it makes recursion.
Yeah.
Will you run out of stack or something?
No.
Okay.
Tail recursion.
Okay.
Where's the closure guy here? Explain tail recursion.
You put me on the spot. I guess you can do it better.
Okay, so in tail recursion, the compiler looks at what's happening and can see that this call to loop is not generating any stack. So it actually makes a call without generating stack. It generates zero stack. So if the last thing in a function is that it calls itself, it basically knows there's no return value, there's nothing it needs to save. You can recurse in a way where you do generate stack, or you can recurse in a way that doesn't generate stack. And Erlang is one of the only languages that can actually tell the difference no matter how deep or how complex your statement is.
Does it reuse the stack somehow?
There is just no stack being generated, so it doesn't need to. The last value it returns directly to. So it just needs to keep track of the last value it's going to return, and there's no stack. So if you look at you have to look in your computer science books, but basically there's no stack.
Assuming that would be using stack, it still wouldn't really use stacks to the recursion if you have the last statement calling itself. Is that correct?
You can generate, like, how's it go? Ilya, help me out. Yeah, I mean, if you did something like this, like let's say in this loop, I'll start out by giving it an empty list. Oops, empty list. And then in this thing here, every time it looped, I took A and gave it like, 5 A. I'm going to have to bear with me on the syntax. A, okay. This is going to generate stack, right? Yeah. Oh gosh, I have to start it up again. So I mean, in this case, what I'm doing is I'm taking a list, and every time I'm calling this list, it's getting bigger and bigger. So as I'm increasing is this tail recursive or not? Ilya? Okay, that's true. Good answer. How do we make this not tail recursive?
1 plus something, 1 plus call.
On the end of here?
You have to return it to, usually if you're doing like factorials and stuff, like the easy way, then you actually start generating stack.
I think the problem is if I do this, if I have something, if this is not the last thing it does before it recurses, it has to keep track of the stack, because if it had a value returned and it was value so if it has to, now it has a problem because it has to keep track of the stack, because it has to work backwards through the stack when it's done. So because I added this after the last statement, it actually now says, oh, you're going to go all the way down, and then eventually maybe it'll stop, hopefully somewhere, and then it returns every step of the way. I'll have to put the value that I just added into there, which is going to mean that this cannot be tail recursive. So this will blow up the stack.
That would be proven still to not to return, because it will never go to the line 30.
Why not?
Because each time it will loop back to the line 7.
But what if eventually, if I count, like if I is 100, and eventually I stop the loop and return?
Yes, but this code doesn't.
Oh yeah, this code doesn't, but yeah, sorry. So I would have to add like, I would have to add a big case statement here and say if it's 100, then return. So then it would come back.
Yeah.
Good point. Oh well, anyways, this is interesting. So we did that. Well, any more questions before I move on?
This process is still a bit similar than Go routines in Go and channels to do message passing between them.
Yeah,
Are there some fundamental differences?
there are.
Why? Okay.
We're getting to those. This is just the first bit, so we'll get to those in just a second.
Can you clarify the syntax minus greater than was used on the?
Oh yeah, and that I actually am going to do this one here. I'm going to, in just a second, I'm going to get to that too. So yeah, this is actually, we use these for a couple of things. This is a case, but this is, you can use it for anonymous functions. And I actually have on the next slide, this here, which Mauna was asking about, which is, do you really write loops all the time? I'm like, no, usually I don't. Recursive functions. I'll use something like this, which is a enum filter. So given a list of things, I want to filter this list. So this is what we call an anonymous function, which says function which takes a parameter, any this parameter. And I'm going to do, if it's equal to fun, then I'm going to do true. So if I had a big list, I could find, actually I have an example of this instead of, let's do this again. I'm pretty sure I have an example. It's easier to see the code. So get examples. So here's a list. This, I'm just referring to these two lines here. So this is how I create a list, and I just want the even numbers from this list. So this means remainder, x divided by 2. If the remainder is 0, this is going to return true. It's a predicate, which means the list will come back with just 2 and 4. So normally that's the way. There's actually a loop recursion hidden inside of there, but you don't have to know about it. You just use this. So this little thing, this data examples, I put some examples of how do you create a map. That's the first thing. What's a symbol? A symbol is just a name. In Ruby, we have symbols too. Lists, I showed you lists. This little funky syntax, this is pushing on the head of a list, so it means append on the front of the list, this new value. There's functions like reverse the list. Actually, you can see in Visual Studio, I get help as well, which tells me everything about how this is used. Actually, it's really cool in the terminal too. You get the same help here. So if I wanted to, there's like h, enum, what functions? Oh, look at all of them. So reverse. If I do that, actually, there's built-in documentation into this interactive editor as well, which even has types as well. Even though it is a dynamic language, it has a type checker as a compiler. So you can use the types if you want to. So this just tells me reverse. I can give it an enumerable, which means anything like a list, and there's an example. and that's what it does. So, questions? Then there's tuples, which are just ordered elements. A lot of languages have tuples nowadays, C++ even. Any C++ people here? No, 1, 2, okay, good, 3, all right, good. And there's also this other funky thing, the pipe operator. Don't get confused with this little thing. It just means this parameter, this becomes the first parameter there. So I only have to, it just kind of puts the first parameter as the first argument. So just, this is my almost end of part 1. I mean, we get into the heavy core, like Go bashing part. No, I'm not going to bash. I was trying not to today. What?
Not even bashing rails.
No, Thomas is kind of hosting this, so kidding. No, we don't bash. So yeah, actually you learned already. This was my quick introduction. You learned modules, which are the things function goes in. You got functions. I showed you if-else, maps, tuples, loops equals recursion, processes that do sending and receiving. That's just about it. There's data types, a string, there's symbols, there's lists, maps, tuples, yeah. And this was, you asked about anonymous functions. That's how they work. There's a few other things. Actually, if you want to see in my code examples, I show you how to do pattern matching, which is a pretty interesting thing, which also is, you guys in Clojure know how to do. Pattern matching is like this. So if you, oops, you don't see that. So Scala actually has pattern matching as well. Actually, a lot of the things in Scala were modeled after Erlang, is the reason why there's those similarities in the languages. Just show you this one last thing. So given you have a map like that, which is a hash dictionary, Python people call them dictionaries, with a couple things in it, then I have this funky syntax where I put this on the right-hand side, but I put this here, and what this is a pattern matching, which means you have a map. I think you have a value in here. This key is like this, and what is that value? So I want to know number 1. So this is going to output number 1. Oh, by the way, this syntax is just interpolation, you know, what every language, even JavaScript has it nowadays. Like print something out. So pattern matching actually is incredibly powerful and used a lot. And a lot of the functional languages have that. Okay.
And for example, in web development, pattern matching in Elixir, so basically most of the routing is done by pattern matching.
Yeah, pattern matching is incredibly powerful. And then there's this thing called macros. Don't do them. No, just kidding. They're incredibly powerful. Because you don't have object orientation, you have a thing called macros instead, which allows you to reuse code. It actually is code that writes code, but it is very technical and very scary. I have probably written only 2 macros in 5 years. So, whereas one guy we work with, Thomas, he's not here, he writes macros all the time because he thinks they're so cool, but they can really create some mind-bending things. So how I work with Elixir, I use Visual Studio Code. You can use Atom, you can use VI, you can Emacs. Okay, Emacs or VI, you guys can fight. Who's going to fight? I don't know. Vim people, Emacs people. I'll show you all these tools anyways. So Beam is actually, you know, Java VM, Beam is kind of like your Java virtual machine. It's actually the virtual machine that runs Elixir code. So some similarities with Java in that we do have a virtual machine that things run in. So, great. So now we can actually get to the hardcore stuff. Unless you guys want a break at all. What time is it? Let's see. Time check. Part 2 begins. Jesus, this is going to take forever to get through these slides. Just kidding. the person in the audience to show me some real shit. So, okay. So in part 3, again, this is in the repo I pointed you guys at. I've included the latest and coolest thing from Elixir, which is Phoenix, which is called Live View. So this is actually a web server web app with controllers here. Everybody knows like kind of concept of controllers and stuff. It's similar to Ruby and Rails, or Python's got them, JavaScript has got controllers. This controller takes a web request, and in this case, when this is a page controller, when it gets a request, it's going to render index.html. So, and as Thomas was mentioning, there is a router. In this case, a router is telling me if somebody is coming into this URL, I want to go to this controller and serve that page. But I'm just going to show you this really briefly because Mauno asked for it. So this is I'll show you what it does first. So let's see. Code somebody would want to see something real. Okay. In Elixir, there's this thing which is called Mix, which is our package manager, which actually it's Hex is the package manager. But this is actually where I declare my dependencies of the different libraries I'm going to use. And they're all, one of the great things about Elixir is a really awesome package manager. So Phoenix is the framework. It's not, kind of like Rails. It's not Rails because it's not your web app. It's actually just a interface layer for the web. And I'm going to, this is what I'm trying to do is live view. So I just have to do one thing because I didn't include, where is it, static? Oh no, is it here? Yeah. Because it uses some NPM packages. It doesn't have to actually, I don't know why it does this, but.
First you read that it has this amazing.
Yeah, I know. So let me just run this. I'll just run this. There's no database here. Oops. What is it? What did I do wrong? What? Oh. Thank you. Who said that? Health bar for him. Okay. Excellent. All right, so what happens when I start I'm trying to start the web app. It's compiling all my files, checking my dependencies, all that stuff. The compiling is incremental. You only compile everything the first time. And the compiler is pretty fast. So it's already running. And what it is a live view, which is this is not so exciting. But the interesting thing about this is that there's a WebSocket connected from the client to the server. And this is 100% rendered from the server. So it actually generates in real time. There's a bunch of demos of this online of serving complete applications with entire server-side generated code, HTML. And the actual HTML, every time I'm pushing those buttons, I'm getting an event handler here, and it's rendering this HTML back to that web page. So it's entirely server-side rendered HTML live with a socket. And you can run this at 30 frames a second and even faster. So
It doesn't set the whole HTML, only the diff.
Yeah, it has a differencer and everything in there. So it's kind of like React, and it has a differencer and says these parts have changed. And it connects it over a WebSocket and pushes it to the client. So this is really pretty cool. Because one thing Elixir is great at is handling sockets. And so there's some real shit. But just to show you that you don't see much, if this is a controller, there's not a lot of that crazy stuff in here. I wish there was some more code here. A lot of test cases. So, for example, here's a test case for me to check. Actually, this is not going to work now because I changed it to the live view. So my test cases are out of date already. The testing in Elixir is also very great because you can actually inspect the syntax tree, which most languages can't do. So, too complex. I'll explain later.
Services that through that web server indirectly for the server side stuff.
Well, I mean, if you can write it however you want. You want to
Yeah.
use React. You want to use. We're using React in one of our projects now. You can just do traditional, database and serve to, HTML, or you can do SPAs or whatever you want. It's up to you. It's an awesome theory. So Erlang, Elixir is Erlang, and Erlang was created 30 years ago. This is, by the way, how did we get here? Oh, that's you. Was that me? Oh.
Yeah.
Don't worry, just leave it. So how did we get here? So this is sort of jumping now into some more theoretical stuff for a bit. So number one, Erlang's about reliability. That's probably my daughter calling. When they created Erlang 30 years ago, they wanted one thing, which was to be able to make reliable code. And so they actually, it was at Ericsson in Sweden, and they were working on phone switches mainly. And there were some guys there who said, well, the easiest way to write reliable code is write simple code. Now, at the time, that was controversial. Nowadays, like with languages like Go and everything, it's like, isn't that, yeah, actually this C++ and things have gotten out of hand, and wouldn't it be easier to write simpler stuff? And then also to if you want to write distributed systems, to write very simple distributed systems. So anyways, but in 2010, I'm going to give you some history of Elixir. So in 2010, Erlang there was this thing called C10K. I don't know if none of you guys are old enough to remember that maybe. But it was like we were making web servers and somebody's like, I'm going to manage 10,000 connections to this web server. And so they call it C10K. And like everybody was trying to make solutions like, how can I manage 10,000 simultaneous connections to my web server? And at the same time, WhatsApp came out and they actually set the record on Erlang. And they proved that Erlang could really be used on a massive, for general, not just telephone switches. So in 2010, Erlang is, if you've ever tried Erlang, who's ever tried Erlang here? Huh? Wow. Cool. So that's great. So it's this. I should have changed this if I knew people from Erlang are here, because they would argue with me that Erlang is beautiful and does not need to be fixed. But a lot of people think it's kind of verbose. I put the period there because every statement in Erlang, like a sentence, ends with a period. It's like most languages use other things or nothing at all. So it's very specialized. Everybody knows it has great networking capabilities. There's like, it's just incredible what it can do. And it's also very open source and very powerful. So Erlang was sitting around. Does anybody know why Erlang is open source? So this is the story. This guy illustrates the thing. So in 1998, Ericsson was working at Erlang, got it to work for the first highly reliable switch, which had 9 nines of reliability. That's like the first time they were downtime of less than 2 minutes a year. Code could be updated while it was running, never dropped a connection. And then the next year, they banned the use of Erlang. This is in Sweden. So because it was banned at Erlang, they open sourced it because they thought, well, it probably doesn't have that much value now that we've banned it, and therefore let's just give it to people. So they open sourced it, which is interesting because why did they do that? Well, at the same time Java and C++ standards were coming out, and programming really turned so that everybody was like, You have to do object orientation. It's the future. It's expressive. There's patterns. There's these things we can do with object orientation. Like, it's the future. And so but guess what? They hired the guys back again after a couple of years and said, oops, we made a mistake. But they open sourced it all. So Erlang is like, everything's open source in Erlang. Well, how did we get Elixir? Well, a bunch of Rails guys. Actually, the guys working on Action Cable, which is how to make WebSockets work with Rails, are the guys who started Elixir. They said, oh, this is a really tough problem in Rails because handling lots of socket connections in Rails and actually talking between the threads or processes is really difficult in Rails, basically impossible. So they were looking for some better solutions. And what they did also like is they liked functional programming and Clojure, and they liked Erlang. And they realized that if they took Erlang, they added a new syntax, added some package managers, did some very nice, that enum.filter is an example of a very nice standard library. They actually kind of copied Clojure's libraries and syntax. And they, things like Phoenix is a new project to make like Rails type of web apps. And it's 100% interoperable with Erlang. So they didn't introduce any new data structures. A map in Elixir is a map in Erlang. List in Elixir is a list in Erlang. So that's where Elixir came from. And basically that's why, even though there's new languages like Go, which are almost 10 years old now, but the stability of Elixir dates to the stability of Erlang itself and the availability of libraries and the robustness and everything else. So now we get into the bashing. Safety, the guns. So this is one of the blogs I wrote about, it's there, well, the world changed. You can see it online. Tom Yoro. So I try to categorize, if you look at memory models, so when who knows the difference between a process and a thread fundamentally? In reference to memory.
Memory production, memory access.
Yeah, threads share memory.
Each other memory one thread can share.
Yes, there we go. Okay, good. Patch this. Ready? Catch.
I prepared here about that.
Oh, shit. Oh, well. Anyway, so I'm talking about memory models. All of these languages here basically have shared memory models, which I categorize as a bumper sticker I see in Texas, which is that, guns don't kill people, people kill people, which means, all right, everybody's got a gun, that's not a problem. Just, don't shoot each other, right? So this is the shared memory. Now, there's other languages, Scholar, Clojure, and especially Rust. I added that there because I wrote this 4 years ago, and Rust was on my list. But these languages, they have things that they're much more, they require any kind of mutability to be very clearly declared and even sometimes isolated from other parts of the code. So I call this as very responsible gun owners because they kind of lock their guns in the cabinet, but they're still there. You can still shoot people with them. You unlock the cabinet and you shoot somebody. Somehow the kids always get in there and shoot somebody. So, and then you come to languages like Elixir, which actually it's impossible to mutate somebody else's memory. There is no shared memory. It's absolutely not possible. So there is no mechanism in Elixir that would allow you to access another process's memory. It's impossible. And we won't go to Haskell, because nobody here does Haskell, do they? Ah, okay. Well, Haskell is kind of weird. I actually crossed out the safer on that because I don't believe it. But it's even more special case. I would argue that Elixir is much more practical than Haskell, but Haskell does do a much better job on large computational problems. So, and I have a slide explaining where Elixir is not good. So not everything is great. So I get to that. So shared memory model, guns. So here's thread 1, here's thread 2. These are this guy's objects, and these are those guys' objects. He's going to do something here, shooting at his object, but actually accidentally hits that object. So that could be a buffer overrun, or it could be, well, you can't do it in Go, but you can get into a situation where you touch, or let's say you had a mutex on a state, and you expected that mutex to be held, and you modified it, and all of a sudden thread 2 is like, I don't know what this is. I thought this was supposed to be this value. So in a shared memory model, you can get a situation where another thread can accidentally screw you up. It could be in a library, it could be anywhere. So let's say in Java, you've got a thread. I've got a thread in Java, and I have a statement in there somewhere. Being a coder, I wrote a while loop, and it just goes crazy. It never ends. Okay, so I've got a JVM running 120 threads. One thread decides that it's going to go into a loop and never stop. Programmer mistake. How do I stop that thread? There's a swag for this answer, and you're not answering it. How do I kill a thread in Java? There's one Java thread. I look at all my threads, and this thread is like, what are you doing? You have to stop. Otherwise, I'll have to shut down the entire JVM.
So back in the day when I was writing games with Java on mobile games, I actually had to do these like state management inside. Like I inherited the class from thread, and it had a state like running or like active or not active. And then if I needed to kill a thread, I actually at first I had to like shut it down manually and then wait and pray if the garbage collector.
Yeah, but let's say it's not responding to you. Let's say it's not.
Well, then there's pretty much no way.
Catch. Whoa. All right, so Java threads cannot be killed. Any shared memory model, Go, Java, anything that uses shared memory, there's actually, by definition, it's impossible for you to say, I want that thread or that process to go away. It's not possible because of the shared state. There's entire academic articles online you can read about, but essentially, the shared memory model would put your system in a very unstable situation if you try to kill a thread. So there's one of the Go answers. In Elixir, we actually have no shared memory. So I can actually kill the blue guy if I want to. I can make him go away. I can clean up all his memory. And I can be guaranteed it won't cause any bad effects for me. So that's number one, that these processes in a web server, and I'm servicing a web request, and one of them in Phoenix goes bad, does something random, gets stuck waiting on a connection, I can kill it, and it won't affect anybody else, guaranteed.
What about if the message, I just intentionally grow the message as large as possible?
What?
Like the message I'm sending, if I'm behaving badly and I'm just upon creating a message and it's like really big,
Yeah.
and then I'm sending it to another process, does the supervisor handle that, telling that, oh, this is too big, or?
Well, there's no too big. There's one way to crash an Elixir beam, which is through overflowing an inbox, the mailbox. That is true. But basically, supervisors can sit up on, in order to have a reliable system, you need two things. You need isolation, meaning this runs independent of this, and you need observability, meaning I can actually look at that to see what state it's in. Is it alive or dead? And I can affect it. So another question is, in a shared memory model, what happens during garbage collection? Answers? Okay, some of these have now been not used anymore, so I got to collect them back into the heap. Garbage collection runs. What happens in Java?
In Java, you sort of stop the universe and do your stuff and then return.
What do you want, patkeys? Yeah. So, right, so we call that stop the world garbage collection. So in a shared memory model, because you've got things, he's got things, you actually have to stop everything in order to count, like, okay, that's yours, that's his, that's mine. Yeah, there are parallel garbage collectors and tricks.
Why didn't I get a practice?
All right. So anyways, in this one, you notice the garbage collector, I have my own garbage collector, he has his own garbage collector. So they're just, and they're actually not mark and sweep, they're actually this tracing kind of garbage collector. So if you look at an Erlang or an Elixir program running, you just see always like garbage is being collected. You never see like, oh, it stopped everything to collect it. It's just always sort of there in the background. And Go. I was running. Actually, I have some Go actually in the code example here. I was trying to compare some Go stuff to some Elixir stuff, and the Go stuff is very easily outperforming Elixir, but every once in a while the garbage collector pauses, and I get a pause, and it's like then it's actually twice as slow as Elixir. So, it's not. Yeah. Anyways, so hecklers, Mauno. There's Mauno. So somebody says, it's just a web app. I don't care. I can just make, like Node, I can make lots of them. And then if it crashes, so what? Right? That's the one heckler. And the other heckler is like, my code doesn't crash. I'm careful. Right? I don't need this kind of safety. So, and then you had one job. So I was probably 18 when I drew that. So yeah, you had one job, right? Our job is to write programs that are reliable, and not because when something goes wrong in a program, it's not just a question of it crashing. It's also a question of potential security, meaning you had something went wrong, your state is unknown, is crashing. You can create all sorts of additional security problems when things crash. Also, it's just damn lazy. You can move you can actually, like, I love that one. It's like, really? So okay, now on to the practical bit. Erlang, before we get back into coding, just a second. So where did this process model come from? So in the beginning, 30 years ago when Erlang started out, they were saying, we want to make a reliable system. How do you make a reliable system? Well, this is how. You have to construct physically isolated components communicating through only pure protocols, meaning they can only send messages to each other. They can't have pointers or share memory or anything. So this is actually a thesis. You can read it online. And it's like the most tandem, and these computers that use reliable systems or anything nowadays is built with redundant systems. That's what we do when we make 10 Docker images and 8 of them fail or something. It's all we know this now. But back in the beginning, I mean, this is a simple premise. So what happens is then, as over time, we start to have multi-core systems. So here's the Pentium, the first multi-core. Now it's like we have 2 computers in one. And the basic idea with Erlang is, okay, well, if we can still preserve this first rule, which is if a process can truly be isolated and in a physical manner, it has no way to mess up another process. And it works with a pure protocol, which meaning sending messages that are actually copies. There's no way to pass a reference. There's only sending data. Then we can run multiple processes on the same machine, just like they were physically separate. So we can get the same reliability of saying, hey, these are like lots of separate. So each process is like totally isolated so that it doesn't matter whether this is here or on the other side. If they're talking to each other, they still have to send messages. So the locality over the network in Elixir, or here's another problem. If you're familiar with multi-core architectures, if you have 2 threads, basically, and this thread is sharing memory with that thread, it can be very efficient because they happen to be running on the same core. If, for example, this guy is going to share memory with that guy, it actually has to go farther down through second-level caches, and it actually empty the pipe. So for almost 10 years, Java's virtual machine could only run on 1 core. I had a 4-core machine. Java only started on 1 core. And the reason was because if one of the threads happened to go to another core, everything got screwed up and the performance died. So Elixir's model of processes and sending messages doesn't have any shared memory, so it can't really get into that situation. So Erlang guy said, let's build lots of little virtual computers, CPUs, on a single computer, but they have to behave like they were physically separated. That also means I can take my process from this laptop and put it on that laptop, and I still communicate it to it exactly the same way. I send a message to it, whether it's here or there, it doesn't matter, exactly the same. It's going to copy. There's no references, so it can't be any different. So, and really build everything on processes. So here's this graph I had. It's another blog of mine, which I wrote, which nobody understood this graph. So when Elixir came out, I'd say, if you had all the problems of the world, okay, what do you guys do? You make image, what do you know, I don't know what you do. We do banking stuff. You guys do IoT or something else, you know. And you say, is Erlang practical for me? You might say like, no. So maybe only like a few, you know, I'm making a telephone switch. I'm down here. Okay, now, like every year, the number of problems where Elixir actually works really well has grown. And the reason is because, you know, we're getting multi-core, we're getting networked, we're getting connected components. All this stuff is increasing every year. At the same time, you know, these coders, like, you know, you're coming along and you're looking at that, Elixir is kind of useless, like, or Erlang's useless, and now there's Elixir here, and all of a sudden, like, there's this crossover point. I've got 16 cores on this laptop, by the way, actually 8, and with hyperthread 16. So unbelievable power, and Elixir is one way to utilize this. So I'm saying all of a sudden, like, people are like, oh wow, Elixir's pretty cool. Do you understand this graph? Is it stupid? So, and another thing is that a lot of this stuff, I guess what I was saying here is that people who are programming with a lot of languages, you know, with JavaScript and stuff, and every year people are saying, make your programs better. Why does it crash? Why are you so stupid? So, like, you know, is there any way, like, to improve reliability? Are there some tools that I have? And maybe it's not, you know, maybe actually programming is kind of hard. And so Elixir's there. So now the third part, this is the last part of this little thing. This is something I wrote. This is the article that blew up on Reddit and has gotten me 10,000 comments. And my premise was don't hog the thread, which I hate. Whenever I read this statement anywhere online, don't hog the thread, I'm like, what am I supposed to do with the thread? It's my, you know, it's my effing thread, right? A thread is there for me to, is there for me to do A, do B, do C, do E, do F, you know. It's my thread. I want to do what I want with it. Why do I have to care about what somebody else is doing? So that was why I was saying kind of this. I was writing some JavaScript and somebody said, oh no, you better not do that long operation because it might hog the thread. And I'm like, you know, what the hell? What year is this? This is what, like, Windows 3.1, 1995, what I was doing. Like, don't use the thread for more than 10 milliseconds because you might slow someone else down. I'm like, look, if you want my thread, take it away, right? So, like, if you do simple programming in a process, you do something. If you have to wait for a database result, just wait for it. Wait as long as you want. I don't care. You're not going to affect anybody else in Elixir. If you're writing code and you need to wait for something, just wait. It doesn't matter. It's your process. You can do anything you want with it. It's not going to, you know, doesn't matter. In fact, you can have as many processes as you want. And this is what I explain here. So, typical web problem. Let's write a web server. What do web servers do? Well, some guys want something. They send requests to the web server. We have things that do things and return result. Everybody know how web servers work? Okay, good. You guys are quiet. How do you solve this this is like the age-old debate. You can solve this by, you can use threads, or you can use asynchronous I/O. So like your node type of solution is non-blocking I/O. So you have one thread and you do like the Windows 3.1 cooperative yields. Can't even say it. Or you do callbacks, whatever. The other thing is like blocking threads. So you can actually create a thread for every incoming process for every a thread for every incoming request, which actually works pretty well. But then again, threads are kind of heavy. So here comes the heavy thing. What do you mean heavy? Why is a thread heavy? I don't get it. So how do different languages do this? I've just got Scala and Rails here, or Java basically. So in Rails, actually, there's like three different ways to do it. You can use a non-blocking stuff, right, which uses like cooperative style, which means all of a sudden this does something that takes a long time and the other person has to wait. Or you can do threads with Puma, which would be like you each get a thread, and that works great until one of them destroys some memory the other guy had, and then the whole thing gets screwed up. Or you can use the forked one, which is a lot of people use nowadays. I think Shopify uses forks. So they actually create separate processes. My problem is this is good, but it's pretty heavy, and you're actually creating an operating system process to manage it. So you don't end up with more than 5 or 10 on your machine before things start like really slowing down. What I want is I like the process type solutions or threads. I want to have isolation. Each request I want to be isolated, and I don't want, I want to have lots of them. So the solution that Erlang or in Elixir is basically you can have as many processes as you want. You can create, hundreds of thousands of them in milliseconds. They're that lightweight. They're like 16K overhead on a process create. And the scheduler actually manages them, and it manages them across all the cores. So now when a web request comes in, just create a process, let the process go do its thing. And you can have as many as you want. Simple concept. And in that process, do whatever you want. That's it. So life can't be all roses. It comes this. Anyways, questions about this before I move on to the roses? Everybody does web service.
So, is it the problem that if you assume that you can at any point kill any of the threads or processes in this case from the chain, that then you need to assume that all this mailbox data inter-exchange can then fail, and everything then must be like timed. That whenever I'm assuming that something, some data exchange happens, it might not. So I end up building like a system internally as if it was totally unreliable.
Actually, that's what the supervisors. No, because first of all, you have observability. So the job of the supervisor, in this case, is to watch processes. And actually, you can create hierarchies. So if you say this one depends on that one, which depends on that one, if one of them fails and dies, supervisor will say, okay, well, you and this one and this other one also have to die. And we'll take them all out at the same time and then bring it back up. And
I'm supposed to then make very well sure that I don't concentrate in one point that ends up killing everything.
Well, yeah, you have to write the supervisors. In a typical application, like we have one supervisor watching our database pools. There's one watching the processes that come in on web requests. There's another one watching WebSockets or whatever else. In general, you can be assured of knowing the observability of the process. You can know there are some situations where you are uncertain if the message gets through. Like Ilya knows this one. The reliability of calling a process, sending a message, in the case.
I can maybe
Yeah.
something that a lot of the thing is that there's no internal state in the processes. When you have this like a recursive loop and a receive pattern, you're always having the process is calling itself and giving out the state as a parameter to the new iteration. So if a process crashes, you can just restart it. The supervisor can restart it using the same state, because the state is like packaged instead of living in variables.
Yeah, and a process can only take one message at a time sequentially. So a process is guaranteed to be one single process, one loop in there. So when you're sending it a message, you know either that it received that one or it didn't, and in between that, the state is known, is what he's saying. Basically, what I'm saying is that it is a little bit mind-bending, but actually the processes themselves are the synchronization primitives in Elixir. So whenever you in another language might use a mutex, in Elixir, you use a process, because process guarantees it does one thing at a time. And therefore, instead of having like a transaction, you would send something to this process, and it takes one message at a time to handle that. It can't be doing anything else.
The other request will go to the queue.
Yeah, the other ones go to the queue.
And if that specific process is then gained, what happens to the queue? It's flushed.
It is flushed.
And whoever sent stuff on that queue, will that process be available to know that okay, my request was flushed, will never complete?
Yeah, well, it can see. You can either observe the process and know guaranteed whether or not your message was sent before or after, or you can create the supervisors which do it for you. So there are some situations you can get into where a process has gone down and you're sending a message to it, and then actually what happens is you will crash as well if it's a linked process, if the process doesn't exist. So the supervisor usually, if it's set up correctly, will guarantee that the state will be known. When this one goes down, you'll go down too. You won't be in a situation where you call processes that don't exist. So normally you don't have to protect your code from calling processes that are not existing. It's a special case. Oh well, I have to show you some code examples, and it seems like our Erlang folks. So that's a good question, actually. It is all completely asynchronous system, so it can't all be roses. So what is Elixir not good for? So some people are probably wondering that, like, okay, Elixir's kind of cool, but what is it not good for? It does all that message copying. Every time you call another process, it's going to copy. So it's not going to be that efficient in certain situations. In those situations, I just put out a few of these, like image processing. If you have 2D index data, you'll find Elixir doesn't work very fast because Elixir doesn't have multidimensional data. You can't like take an image array and say 5, 3. You have just like arrays of rows of pixels, for example, and you would have to, and every time you changed one, you'd have to get a new one back. So you're having a lot of, if you're trying to do a lot of mutability of a very complex data structure, it's not going to work very well. Game engines do the same thing. Game engine state, there's mutations happening all the time on a very complex data model. Not that great. So high performance compute engines, those type of things are not really ideal for Elixir. So, but just because you have some part of your program that has something that's either not safe or needs to be fast, usually things that need to be fast are very high performance. Typically are those parts that are also not safe. So because you're using indexed data, you could have problems like in C++ of going off the end of an array or something. So in Elixir, what we typically do is we put them in a different part. Actually, in our face payment server, we have one part is in Go, and that part does a fill. Actually, I included the source code if you want to see it. But it does a filling algorithm. It takes an image and its depth data actually from an image, and it goes through to try to fill in holes. So there's some holes in this image, and it tries to filter them out. And that we actually run in Go, and we pass it the image, and it does it in Go, and we get it back. So so you don't have to write everything. Elixir is really good at interfacing other command lines, sockets through ports. You can actually even run a binary on the beam. You can actually run native. You can make like a Rust application or even a C application and actually run it in the beam, which is a very bad idea because you could potentially crash the whole beam. That's why I recommend using Rust if you, not Rest, Rust. It should be Rust. Correct. That should be Rust. Because Rust is one of the only languages that actually can guarantee it won't leak. So you can actually run like a Rust image processing algorithm in the beam in a guaranteed way that it's not going to crash the beam. So there's very few languages. Rust is really cool. Oh, that is Rest. Sorry, you can call Rest. Well, I didn't say compile. Rust is a good way. This is Rest. So you can just make HTTP call. So questions before, can we get back to coding? So it's very cool, but can it really work? I mean, you've got immutability, meaning you're creating objects like crazy. Every time you make every time you change something, you get a new version. So Is that going to work? You're copying, every time you send a message, you're copying it. Can you really create 10,000 processes just like that? Can you really solve all your problems with very simple data structures like maps and tuples and lists? Can you live without object orientation? I don't know. I'm not convinced about this things crashing and managing, and shouldn't I handle the errors? Why should a supervisor handle errors? So when I started with Elixir 4 years ago, I asked myself these same questions. Are you guys asking yourself these questions? Anybody thinking about these things in their head? Okay, good. So try it yourself. So what I did is actually, in my GitHub repo, when I first started using Elixir, I said all these things. No way is this going to work. I'll write some things in, I wrote a thing in Ruby versus Elixir. So I wrote this parser in Ruby, and I thought, this is pretty efficient. And I said, okay, I'll do the same thing in Elixir. This cannot work, right? It's just, I mean, every time it goes around, it's creating new objects, and it's like, oh, this is going to create like, I calculated like, Ruby has like 200 news, but like, you know, maybe 5,000 mutations. And in the Elixir, it was going to creating like 10,000 new data structure, basically every time I changed it. Every time I mutated, it made a new one. And actually, the Elixir outperformed the Ruby. I couldn't understand how that was possible. But it turns out the garbage collection is incredibly efficient. So as fast as you can make new things, the garbage collector is like running right behind you, cleaning things up. It's very efficient to know, because it's so simple, data structures, it's very efficient to know what is actually ready for garbage collection. So then I also wrote a parallel map reduce. So the idea was I have this big list, and I want to do an operation on it. So I'm going to create like 5,000 processes. They're all going to calculate it, and they're going to send me all the results back. And then I'm going to try that. And I want to see my CPU, I want to see every single core go like that. And it works, just like that. I mean, the code is all here. I mean, it's pretty amazing. So, and there's even some Go stuff. All right, last thing. Here's a game for you guys with swag. And I don't know how to do this interactively, so I'll just have to do this way. This is a guess the language game. So, your choices are, get rid of this. Schedulers, cooperative scheduling, which means you give up the thread, lightweight green threads, preemptive schedulers, or multi-core preemptive soft real time. Okay, here's the choices at the bottom. Anyway, so there's simple languages, there's complex languages, which are mixing both object-oriented and functional, dynamic, not dynamic, garbage collection types, clean it up yourself, stop the world, or per process. There's virtual machine, no virtual machine, and then over here there's languages that are guaranteed isolated, memory safe plus checked, memory safe, memory not checked. So your choices are Ruby, Elixir, Go, Java, JavaScript, C++. Ready? First one to shout wins. Okay, here we go. I don't know if this is going to work or not. I'm going to pick at random. Okay. Which one is that?
Go. I don't know.
Why not?
Virtual machine. Basically, runtime.
It's Go. It's Go. Okay. One for you. We'll just, how do you want it? Okay, here, fine. Okay, Go was handled. All right, next one. Let's turn this one. Okay, so I started on this one. Let's do this one. So it's very similar. What's that one? Java. Very good. Java. So Java has got a preemptive scheduler, right? It actually uses real operating system threads, which means it will take the thread away from you. You don't have to do anything. It'll just say your time is done. It's time for somebody else to run. It is having both object-oriented and functional nowadays. It is actually not dynamic, sorry. should be here. Oh well, anyways, it has stopped the world garbage collection. It has a virtual machine. Blah blah blah. I think it should be. Okay, what's this one? Cooperative scheduling should give a hint. There's only one language down here that uses cooperative scheduling. What? You said it, what? JavaScript. You already got one.
I'm not sorry.
It's JavaScript, right?
Not memory safe.
He said JavaScript?
Yeah.
Oh, okay, here, catch. Ready? There. Okay, fine. Okay. A few more left. Wow, who said that? That was fast. Okay, very good. Yes. C++. Oh, you got two. All right. Anyways, it's of course it's real threads. Actually, the thing is, C++ can be everything.
Yes. Well, I was waiting when it's everything.
Okay. I know, but I'm just kind of being typical. All right. It is actually C++. One of my friends in the U.S. always tells me C++ can do everything. I'm like, yeah, but you have to implement the cleanup. You got to do it yourself, right? Okay. Yeah. Do it yourself. All right, fine. How many left now? Thomas, are you going to answer this?
No. Like the one answer from the list.
Yeah, haven't we done all? We've done all the others. All right, no, there's two left actually. It's either Elixir or Ruby. It's Ruby. All right, give me a break, guys. Okay, and then all right, there it is. So that's Elixir. So it's it's only one with guaranteed isolation. It does have a virtual machine. It has the only one with a per process garbage collection. It is simple and it is less flexible. I used to have flexible, not flexible, but it's also the only one with a real soft, real-time fair scheduler built in. So
Tom, is it one thing that catches the eye is that here you equate simplicity or complexity with object orientation.
yes.
Care to elaborate on that?
No. Yes. Well, I didn't actually refer to, well, I guess I did. What I was saying is that languages that mix the object-oriented and functional paradigms tend to be complex when they have both.
But that is like literally almost every language nowadays.
It is. Except languages like Go, they don't mix.
Yeah, or Elixir.
Or Elixir, yeah. So there's a few new languages that don't mix object-oriented and functional. So, some of them, like Ruby, mixes it, and it's really beautiful the way Ruby does it. So, but it is a lot more complex. Yeah.
Except when you get bigger at LNK at some point, then thought that actually the way Erlang and Elixir does processes is almost the pure object orientation.
True. Very true. So yeah, some people say the process model is the actor model, which is the original form of object orientation, meaning objects talking to other objects, isolated state. So it can be argued that Elixir is also is object oriented. So, but it gets kind of weird in people's heads because it's like, okay, if you want the coolest object oriented thing, everybody knows the coolest object oriented language out there, right? Nobody knows it? If you really want to go, no. Small talk.
Yeah, but how do we how do you imagine that we measure this complexity? Because if I were to ask the crowd here, I would imagine that a lot of the people feel comfortable around OO and they don't see it as a complex thing because we have been so accustomed to it, right? Like we've been programming in OO for so long that it's like second nature, and moving from OO to purely functional non-OO language, it's gonna twist your mind at first, right? It happens to everyone.
Well, is JavaScript object oriented?
Yeah, sure. Of course it is.
Prototypes, not really objects.
Classes. Inheritance. It is
Nowadays, originally it wasn't. But prototypes are not necessarily really objects, but it's another thing. Yeah, I don't know. We could have a quiz. Who thinks object-oriented is equal to complex? Okay, who thinks object-oriented? Okay, who's on the fence? Everybody. So that's about 50-50. You're going to raise your hand.
Yeah, it's good. I mean, like most of the trouble I had, like I think it's make the modeling easier, object-oriented. Like when I was, well, I have in couple of occasions I have had really troubles of adjusting my programming style when I have switched language. The other was from Java to Ruby, even though Ruby has the classes, but it has also the modules and mixing stuff. So it was really confusing and that kind of things. But also when switching from programming Java to C# and Unity, and it has the entity component system, and it was really hard time figuring out like how can I program with this and like not use the classes like I used. And but like for me with the Elixir, to be honest, and most of the new stuff today, because I'm now doing serverless, so I'm just like wondering like what is the problem they are trying to solve, because like for me and what I've seen that especially with all the new projects we are making, we don't have the scalability issues, we don't have the users, and like we can basically run it in anything and just push some race up to Heroku and just use it and it just works. So I don't understand these selling points these days, especially with the serverless. You can just, well, you didn't have to manage your own servers and you can just scale them like in the cloud, and I was like, well, I don't have the scalability problem, so like why would I change to this new type of programming model when I don't have the problem in the first place? Just so like what is the like the
scaling?
Yeah, like I don't like what is the selling point for Elixir? Like
well, I mean,
one
like because
yeah,
just that like most of the time, at least for me, it's the like the productivity thing.
Mm-hmm.
Last year I was programming stuff with C++, and when I got pretty good with it, I realized that well, these problems has been already solved with the game engine, so then I didn't actually. So is this part of like just using the language because it's fun to use? Because I think many of the new things are based on that, I think, as well, which is good, of course. Like you wanna enjoy your work when you're programming. So
Antti needs to say something.
Well, yeah. So like GitHub is running Rails, right?
yeah.
Yeah. So
Heavily.
works.
Yeah.
Even Rails, which is
Yeah, and Shopify.
slow.
Yeah, and Shopify.
Yeah, and Shopify. Yeah.
Yeah.
But like one of
Stuck with the garbage collector, or gets stuck doing some in that situation. So yeah, I mean, there's certainly big sites, and but I mean, for me, the if I had to write a web server app thing, I think I'm more productive in Elixir than I am in Rails nowadays. I mean, I can just as easily.
Yeah, I'm just meaning that there's still the learning curve. Like there's just so many languages these days. I'm just getting tired. Like all the time read the new language and then you just go through the same kind of things. You know that well, I can do this in this language and this language already, but this is the same shit, different language, and it just happens to be some language which.
You remember that you have one job slide.
Yeah.
Okay.
Yeah. But I think you get the point.
Serverless thing was interesting. I was wondering because we learned that Elixir is fast. Specifically, it's fast to boot. The loading time is fast. So if I have ABS Lambda 1 second, how many times I can instantiate with that standardized process Elixir function which loads from nothing.
Yeah.
Because that sounds like that we can make things cheaper.
In Elixir, you mean? Yeah. I mean, in Elixir, I mean, we had one guy. We redid some of the interfaces to our cache process, one of the payment processors, and we made a component, and we said, yeah, don't worry. And they said, what about performance? He said, don't worry, it's fine. And he came back, he said, look at this performance, it's like 400, you know? And I'm like, those are microseconds. like, oh, there's a little microsecond. Actually, it reports you microseconds on the response times because it's like a lot of times it's like, did it just do the whole stack in microseconds and respond? So I actually had a slide about Lambda on here, but it is so controversial that I didn't want to get in trouble because I took it off.
Lambda one.
Well, Lambda's look, it's going the right direction. Lambda's premise is, hey, functions are isolated, right? You don't share anything with any other function, so you get a guaranteed isolation. So when that function runs, it's not going to corrupt anything else. So which is nice, and basically you can have as many as you want. You can have they get expensive. They're very expensive actually. So you do get a couple of the things that you get in Elixir in Lambdas, and I think that's one reason Lambda is popular. And in a way, they're trying to replicate a lot of the stuff that is built into Elixir, is isolation and horizontal scalability. But the problems I have with it is that the model locks you into one way of thinking of the world, which is in terms of process invocations. So like if I start one process in a Lambda, and I have to do what I call like a scatter-gather, so I start 3 other processes, and then I realize that, oh, my guy is waiting on the other end of this connection. I need to respond to him. So I say, oh, I'll respond to him. Oh, guess what? All of these things just stopped. I can't ever do it. So I'm tied to the function lifecycle request response in order to do all my stuff. So then the Lambda guys came to me and said, oh yeah, but you can create a step function. I said, what the hell is a step function? Well, it's a thing that gets you call other processes because this process can't wait. And I'm like, I'm back to, why the hell can't I, it's my fucking process. Like, why can't I do what I want with it? Now I'm programming around the Lambdas sort of things and trying to add step functions. And basically they're trying to solve similar problems, which is the configurability and the isolation and this horizontal scalability. It's just I don't like number one, step functions are like 10 times more expensive than normal functions. So if you have a function which like you define steps for it, like it actually costs 10x. And I've seen some of the numbers, and it's just crazy. It's just a little function. It just like does nothing.
Yeah.
It's just like.
Yeah, just to add to my comments, I'm not trying to bash the Elixir. I'm just trying to figure out like which part in my tool it could fit.
Yeah.
Like I know like even though I don't like serverless, and there are like many things which I don't like, but like there are some use cases like especially if I'm doing some static blog and I need only like the subscription or something, I'm not using MailChimp. I could just do the Lambda function and I don't have to set up.
Yeah, no, absolutely.
Or do some like SaaS application or something which is just offering services via Lambdas and that kind of thing. So
yeah, I don't. Each one of them.
Can you run it on Heroku or like what is the deployment on?
Yeah, they have one.
But like I think that like now when we are talking about web development, web apps, the database is always the slowest one. It doesn't matter if you're running Django or Rails or Elixir or whatnot.
It does.
I mean,
it does.
When you don't have any indexes in the database, like it doesn't really matter.
Yeah, well, here's the thing though. I had another slide about this, but this is again an advanced topic. The problem, why is your database being used so much?
I mean, the state.
Because you're writing stateless components.
Yep.
And why are you writing stateless components? No. No, see, the problem with that is that every single little thing you end up writing to the database because you want to write something stateless, because if it crashes, you have another one. Yeah, but actually,
it comes from the HTTPS.
No, it doesn't.
I mean, that's stateless.
Well, it is, but you construct state. You have a session ID, right?
Yeah. So, that's not a protocol.
So I'd give you an example. In face payments, we actually can scale on a single server to the entire transactional volume of Europe. And the way we do it is we run we model stateful like transactions, for example. So the states update on the object, but they write behind to the database. But they actually, we look at the states and we say, actually, we don't need like there's 4 states we go through, we don't need to persist. If something goes wrong, we know we're going to have to roll back to this point anyways. So the only reason we actually write to the database is when we get to a point where if something crashed or something happened, which it never has, if it did, we'd have to be able to recover. So, but the intermediate states, we don't have to write because of statelessness. We actually just run it stateful. So I actually believe, there's another blog I was working on, which I believe the future is stateful stuff because of this database problem. Because when you write stateless stuff, you end up hitting the database every single time. Like in a Lambda, you have absolutely no state. You have to load your state every time for a function from a database. Even, I mean, it's insane. Why can't you just have some state? So, like for us, when you have a connected terminal and a socket, and you have state, and you can model things in a reliable system. You can model things reliably in memory, so you don't always have to hit the database actually just to save state. So, so we get a lot of scalability doing, and I think in the future we're going to be doing that more and more, because in the future what will happen is you'll have a database and somebody will say, just load the database into memory. And you say, what, like 2 tera in memory? Yeah, I got plenty of RAM. And the whole database will be in memory. Like it'll be, like you get so much memory nowadays, it boggles my mind why we're still in this stateless world when it has nothing to do with what the capabilities of our systems are.
With Elixir, you talk about state. This was an idea. Can you, when you are doing receive, so you are doing that I am awaiting with my state of my inbox, can you put it into disk?
Yeah, you can. Oh, no.
Is such used?
Yeah, I mean, I have a couple of books with me. So what the state of a process is kept alive because it's looping and its state is going back to itself, right? You can, we use databases in our processes all the time. And what we do is when we actually look at our state changes, and when the state changes to a point where we say, hey, this is a transaction we can never lose, like this state we have to know. So for example, in face payments, we're recognizing somebody's face, and we get to a point where we say, okay, yeah, we got it. Okay, then we need to transact that, and then we'll write to the database in the process. But the other state is not, because what happens is, oh, gee, this crashed. Well, you're going to have to start over, send me some new images anyways. So why would we bother saving that to a database? So anything that we know is not at a point that we need to have the transactional database capability, we don't write. But yeah, you just write ecto write to database in your process, and it'll write it out. So yeah, you can actually Erlang also has a built-in database. It also has a built-in way to share memory in a safe way. So there is a global thing called Erlang Term Store, which allows you to put things like, for example, registry. If you're looking for a process you know by a name, it's in a registry, which is actually a global state. So you can actually share data in this, but the difference is that it uses the Erlang primitives, and there's no way for you to actually share the memory, but it's held in a safe place. Oh well, you have to read up on it, but so you can use database. We use it all over the place in the process. Just write to it. Yeah.
So actually now we're running out of
Yeah.
2 hours, and like really fast. We have like the last slide.
So, Mauno got me in the, show me some real stuff, which I did. I was going to show that now, but it is in the code. If you clone my repo, you guys can look at, it's a live view demo, which is really cool. I think you can read online about live view. And Ecto, how to use the database. I mean, we could do more practical stuff, debugging, that kind of stuff. No, I think that's about it. Anybody, any last questions? I'm all. So the premise of the talk was, yeah, what's your question?
So do these processes have priorities? So how the pair, you said it's pair on scheduling, so it's just equal slice, maximum duration slice, which gives
Yeah.
very simple scheduling.
Well, it is the most complex and best scheduler in the world. It actually creates a new scheduler for every single CPU, every single core you have, a separate scheduler. And every single operation, it counts how expensive it is in terms of this thing called reductions. So it's actually trying to compute the time resource usage of every single, that's why it's soft real time, because it's not just time based, it's also resource based. So it's a very complex topic. It's 30 years evolved the scheduler. So, but that's why it's soft real time, because it prefers fairness always. Like other languages like Go and stuff will prefer performance a lot of times, which is saying, hey, I can let this run faster. It's okay if this guy has to wait. Where Elixir will always prefer, hey, you got your process needs time, your process. That's why it's my thread. I can do what I want, and I'll get scheduled.
When the cake is too small for all the people, how it shares fairly?
Well, again, it can go up to, I was trying to look at the numbers because I knew somebody would ask this, but it was, into the hundreds of thousands into millions of processes before it starts having problems. So if you've got 300,000 processes, it's still scheduling them and fairly. After that, it starts having problems. So at that point, though, you just take it and run it on a different machine. You say, oh, that stuff can run over there, and you just move it. And then it clusters, and your code's the same. So anyways, to summarize, this talk was about Elixir and safe practical. The point was that you can actually have the Elixir as a language that gives you a lot of reliability and safety, and it actually is very fun to work with and easy to work with and solves most of, I think, the problems that we all are working with here today. There are some cases that are not so great for Elixir, but didn't want to bash on any other languages. I've used them all. They all have their places where they're good and bad and stuff, and sometimes better. So, try it yourself, and if you have any questions, contact me. That's it.